Hello mathematicians, thank you for joining me again today as we try to approximate the area under the curve of x equals 2x cubed plus 3 on the interval 0 to 4, and we're going to do that using a right Riemann sum approximation with 4 rectangles. As we begin this problem, what I'd like to do is just get graphically an idea of what's going on. And so if I graph 2x squared plus 3 on the interval 0 to 4, I'm going to have a function that looks like this. It's going to look like a parabola. We're only interested in the interval 0 to 4, and so I'm going to graph that. And the area I'm talking about is the area below the curve and above the x-axis, which I've marked in here. Now what I want to point out is that if we were trying to find that area exactly, notice that this isn't a nice geometric shape, so we can't just use a formula and be done with it. Instead, what we have to do is some other type of technique. And we will find ways to do this exactly in the future, but right now what we're going to do is just try to approximate the area under the curve. And so the idea is that if I draw rectangles to approximate the area under the curve, if I drew something like this and found this area, while not a great approximation, this area would be approximately the area of this curve. I could then make that area better by using more rectangles, so instead of 1, I might use 2. And then I can find these 2 rectangles, and this area and this area is closer to the orange area than the original one was, but it's still not exact, so again we would want to make it better and better. Now what we're going to do here is we're actually going to find R4, that is the right Riemann sum with 4 rectangles, and so as we do that we want to first start off and just say, okay, what does that mean? Now, because we're going to use 4 rectangles, we want each rectangle to have the same width, and we need to cover the entire interval from 0 to 4. So because the interval from 0 to 4 is going to be 4 minus 0 equals 4 wide, I need to cover that with 4 rectangles. So I'll divide by 4. So I'm going to take my left endpoint minus my right endpoint and divide by the number of rectangles. And I'll notice that in order to have equal rectangles, each rectangle would have to be 1 wide in order to cover the interval 0 to 4 with those 4 rectangles. So now that I know that, what I'm going to do is partition the number line off every 1 point so that I know where my rectangles are. So I'm going to have one starting at 1, 0, and ending at 1. And so I'm going to draw a vertical line here denoting the end of one of the rectangles. And the y-axis would denote the other end. I'm going to move on one more. So 1 plus 1 is 2. So I'm going to draw a vertical line at 2 to denote that is the endpoint of that interval where that rectangle will be. Then I'm going to move one more. I'm going to draw a line at 3 to denote that endpoint of the rectangle. And the last one will be right at 4. So I'll draw that line up so that I know where the subintervals are that correspond to each of my rectangles. Now that I know the width of each of my rectangles, I need to find the height. So now in order to find the height, what I want is to say, well, because I'm using a right Riemann sum, I'm going to use right endpoints of those subintervals. So now if I look at the subinterval 0 to 1, the right endpoint is 1, which means that I'm going to use the point 1 and plug it into the function, which is going to give me this value here. And that's now going to be the height of my first rectangle. So my first rectangle is going to look like that. To find the height of my second rectangle, I'm going to plug in the right endpoint from 1 to 2 is 2. I plug 2 into the function. This is my height on that subinterval. So now I can draw on this rectangle, which is going to look like that. If I do the same thing from 2 to 3, 3 is going to be my right endpoint. My function value is here. I'm going to draw a vertical line there. And so I'm going to say that that is going to be my third rectangle, and I'm going to need to find that area. For my fourth rectangle, I'm going to plug in, well, from 3 to 4, the right endpoint is 4. So I plug 4 into the function. I use that as my vertical line, and now I get that my fourth rectangle will look like that. Therefore, what I'm claiming is that the area of the curve under the curve is approximately the area of the sum of these rectangles. So now what's left to do is define the area of each of those rectangles and then add up all of those areas. Alright, so now that I want to find each of these areas, I'm going to look at these rectangles. This is area 1. We said that the width of this rectangle is 1, and so the area of a rectangle in general is width times height. So I'm going to say the width is 1, and now I need to multiply by the height. Well, how did we find the height? Is we took 1 and we plugged it into the function value. So what I get is that the height is just going to be f of 1. So now if I want to find the area of the first rectangle, I'm going to take 1 times f of 1. Well, f of 1 I plug into this function. I get 2 times 1 squared is 2, plus 3 is 5. So the area of the first rectangle is 5. Now I can do the same thing for the second rectangle and say area 2 is going to be, well, the width is still 1 because each of the widths the same, but now the height is found by plugging 2 into the function because that was the right endpoint of this subinterval. So if I plug 2 into here, I get 2 times 2 squared plus 3 is 2 times 4 is 8 plus 3 is 11. And so 1 times 11 is just 11, so this area is 11. Moving on to my third rectangle, I get that the width again is 1 and the height is, well, what I'm going to plug in here is the right endpoint on the interval 2 to 3 was 3. So I'm going to plug 3 into the function to find the height. Now if I plug 3 in, I'm going to get 2 times 3 squared. 3 squared is 9, times 2 is 18, plus 3 is 21. So 1 times 21 is 21. So the area of my third rectangle is 21. Moving on, I have the area of my fourth rectangle. Again, the width is 1, but the height is going to be, well, the right endpoint from 3 to 4 is 4. So I would plug 4 in. And so now f of 4 is going to be 2 times 4 squared plus 3. Well, 4 squared is 16. 16 times 2 is 32. Plus 3 is 35. 35 times 1 is 35. So the area of the fourth rectangle is 35. So what that means is if we combine that together, my right Riemann sum approximation with 4 rectangles is going to be area 1 plus area 2 plus area 3 plus area 4 is 5 plus 11 plus 21 plus 35. And if I add those together, I get 5 and 11 is 16, plus 21 is 37, plus 35 is 72. Hence, the right Riemann sum approximation with 4 rectangles for this function on the interval 0 to 4 is going to be precisely 72, which means that the area under the curve is approximately 72. Now, if we actually look at the picture, we notice that we're actually counting too much area, so the actual area will be less than that. If we wanted to find it exactly, or a better approximation, we could use more and more rectangles, but at least for now we have an approximation which gives us an idea of how much area is underneath the curve. Thank you for watching. As always, I hope you learned something today, and I hope you enjoyed the process along the way. If you did, make sure to like the video and subscribe to the channel. It helps me to know which videos are helpful, and it helps other people to find these videos so that they can also get help. Thank you.